These are the practice problems for Lesson 9, solving problems about proportional relationships. And the first problem asks, is there a proportional relationship between the number of sheets of paper and the weight of that paper? And so look for the two properties. So that's what we've been doing all along. So the two properties are the weight of the paper and the number of sheets of that same paper. Now the sheets are all the same size. They're a standard 8.5 by 11 inch sheet of paper. So you can write the relationship. All the weight's the same, so the weight is equal to the number of sheets, and that's connected by the weight per sheet. So weight equals weight per sheet times the number of sheets. And so the connection between the two properties is the ratio of those properties. So if you know the weight for one sheet of paper, and you're given, I have 223 sheets of paper, and I know the weight for one sheet, then you just multiply 223 times that weight, and that gives you the weight of the whole stack. So it is a proportional relationship. So weight is equal to the weight of one sheet of paper times the number of sheets of paper. It's called the constant of proportionality, and this is simplified to the unit rate. So one goal of many of these problems is to take the constant of proportionality and simplify it to what is the ratio for one unit. Sometimes you don't want to do that. Most of the time you do. On the other hand, what if you have a stack of different sized books? Well, because they are different sizes, they don't have a standard weight. So if you create a stack of books, there's no one factor or one constant of proportionality, one number you can multiply the number of books by to get the weight. So there's no, it's not proportional. There's no constant weight per book, and there's no constant of proportionality. So that stack is not proportional. The weight of the stack is not proportional to the number of books in that stack. This is problem number 2, and this is about a toy and the batteries that are included with that toy. So for each toy, you get 2 batteries. So what's the proportional relationship? Well, write down the 2 properties. One property is the number of toys, and the other property is the number of batteries. And they are connected by the ratio of toys to batteries or batteries to toys. Now there's 2 batteries per one toy, so we can begin there. And so yes, there is a constant number of batteries per toy, so there's a constant proportionality. So it's either what we wrote up here, 2 batteries per one toy, so that's this one, 2 batteries per one toy, or it's 1 toy per 2 batteries. Now notice, if you simplify this one, or if you write this relationship as the unit rate, it's going to be a half of a toy per 1 battery. Because if you have 1 battery, that means you have a half a toy. Well, it doesn't make any sense. You're going to have at least 2 batteries because you need at least 1 whole toy. But, that's a way to look at it. So get used to looking at these relationships as reciprocal relationships. That's the other term for that is the multiplicative inverse. So 1/2, the reciprocal of 1/2 is 2, or the multiplicative inverse of 1/2 is 2 over 1 or 2. So then write the equation. So B is write the equation where batteries equals how much, or toys equals how much. Well, batteries equals the ratio of batteries per toy times the number of toys. So if you're given the number of toys, you multiply by this ratio to figure out how many batteries you get. And the batteries per toy are 2 batteries. So if you're given 5 toys, you're going to have included in those 5 toys 10 batteries, because 2 times 5 is equal to 10. On the other hand, if you're given the number of batteries, how many toys did you purchase? If you take all the batteries and you count them up, how many toys did you get? Now you have to have an even number of batteries. 2 batteries, 4, 6, 8, 10, 12. So let's say you have 12 batteries. That means you have 1/2 as many toys. So 1/2 of 12 would be 6 toys. So the number of toys is equal to 1/2 the number of batteries. If you had bought a bunch of toys, take all the batteries out, it has to be an even number. You could not have bought a half a toy. Now you could have lost one of the batteries, and that would change the calculation. This is problem number 3. Lynn and her brother were born on the same date, but in different years. So Lynn was 5 years old when her brother was 2. So it says find their ages in different years by filling in the table. So Lynn is always 3 years older than her brother. So her brother's age you could write as y, if this is the y value and Lynn's age is the x value, y is equal to x minus 3, because her brother is always 3 years younger. So when Lynn is 6, her brother is 3 years old. When Lynn is 15, her brother is 12 years old. On the other hand, Lynn is always 3 years older than her brother. So when her brother is 25, Lynn will be 28. So 3, 12, and 28. So there's no constant of proportionality. Actually, it's a subtraction problem when you set it up. It's not a y equals kx or a multiplication problem. So that's a hint right there that it's not a proportional relationship. But Lynn is always 3 years older, so there's no constant proportionality. So if you divide y by x, you're not going to get a constant amount. Actually, you're going to start out with a very small amount, 4/10. For example, in the very first age is given. And as they get older, notice that this number, that ratio, gets closer and closer to 1. 25 divided by 28 is 9/10. This is 8/10, 5/10, 4/10. And the reason for that is as they get older, they're still only 3 years apart. So that difference has less and less meaning as they get older. So say, for example, that Lynn is 100 years old and her brother now is 97. Well, you're going to look at that and you're going to say, well, there's not much difference in their ages. So it's close to 1. 97 divided by 100 is 97 hundredths. They're old, not much difference. So there's not a proportional relationship between ages because they move together. They're always 3 years apart. It's not through multiplication. This is problem number 4, and in this problem, a student looks at this equation, y equals x divided by 9, and says that's not a proportional relationship because the relationship between x and y is division, not multiplication. So you need to multiply to have a constant proportionality and to have a proportional relationship. And so do you agree or disagree with that? Well, in fact, you should disagree, because multiplication is the inverse operation of division. Because x is being divided by 9, that's the very same thing as multiplying by x. So you can always write one as the other using the multiplicative inverse. So if you rewrite this as x divided by 9, if you use the inverse operation, which is multiplication, so now it's going to be x times, and what are you going to multiply it by? You're going to multiply it by the multiplicative inverse of 9, which is 1/9. So if you're going to use the inverse operation, you have to use the inverse of the number, which in this case is the multiplicative inverse, which is 1/9. So if you look at this, now you have 1/9 times x, that's the same as x divided by 9. And now if you multiply these together, x times that 1 is equal to x, you actually get this back, x divided by 9. So they are the same thing. They're just written as inverse relationships. So one is division, the other is multiplication. Now you can't take a number and divide it by x. That is not proportional because it has to be the operation on x. If you multiply a number times x, that's the same as dividing. Or if you divide x by a number, that's the same as multiplying, using the multiplicative inverse in each case. This is problem number 5, the last problem in this problem set. It says quadrilateral A has side lengths of 3, 4, 5, and 6 units, and quadrilateral B is a scaled copy of quadrilateral A using a scale factor of 2. So it says select all the following that are side lengths of quadrilateral B. So if you look at these lengths, can they be lengths of quadrilateral B if it's a scaled up by a factor of 2 of the first quadrilateral? Well, what I did is I wrote down the lengths, and then I multiplied each of these lengths by 2 because it's a scale factor of 2 to get the scaled lengths of quadrilateral B. So 3 times 2, 4 times 2, 5 times 2, and 6 times 2. Then you just have to look over here and see if in fact those numbers show up over here. And where they show up over here, those are lengths of quadrilateral B. And the ones that show up is 6. So B is a correct answer, and 8. D is a correct answer. 5 is not a length of B. 7 is not a length of B. And 9 is not a length of B.